Hi, everyone. Thank you for taking the time to listen to today's topic, Secure the Data Cloud. My name is Gopal Raghavan, and I'm with CLOUDERA's Partner Programs team. Before we dive into what securing a data cloud means, let's set some context first. All enterprises have a goal of building an enterprise data cloud, which covers the data lifecycle stages shown here. In the first stage, you collect data from various sources. In the second stage, you enrich, augment, and curate all the data sets. The third stage is reporting on this data for insights. The fourth stage is serving up a subset of the data for low latency real-time use cases. The fifth stage is applying machine learning and AI to create prediction models to make the enterprise data-driven. So enterprises are also looking for a common security and data governance layer to manage all the stages in a very cohesive fashion. So we at Cloudera have a lot of validation from both our customers as well as the analysts that there is a large need for this. Generally speaking, our customers have said that if you've got it, we want it. The customers and analysts have their own spin on things, but it's referring to the same kind of technologies. Even competitors like Snowflake are using terminologies like cloud data platform and so on and so forth. So the question is, how do you get to this architecture? Customers took two different paths to realize the goal of the enterprise data cloud. For the first path, they started off 5 or 10 years ago. So they initially started with something like CDH or HTTP with an on-prem scale-out architecture, which is now known as the data lake. This data lake was envisioned as a place where people could pool all of the data in a centralized location and perform processing on that for insights. From there, they wanted to adopt a more efficient manner of using their infrastructure, which is when they started to adopt the public cloud infrastructure. There, they found some challenges. So typically, the customers that have moved their CDH or HTTP clusters to public cloud like AWS or Azure were not very happy in that state and started to look for a more efficient destination for them. And that is the enterprise data cloud. So in the second path, they start with native cloud providers like AWS or Azure, right? So over time, their business requirements get pretty complicated. And this is due to maturation of the business. As an example, a social media, web, and mobile application company had simpler business processes and model before they went public. After they went public, there were a lot more processes that were put in place. And additionally, there were processes to help them manage regulatory and compliance guidelines. What is interesting here is, regardless of the path they take, they want to realize the goal of getting to enterprise data cloud. So when we say secure the data cloud, it means many things. So the first thing it could mean is better platform security and data protection. And as you know, HTTP and CDH provided pretty robust capabilities around this particular area. So they not only did a pretty good platform security, but also did a lot of work around protecting your data assets. And this is what the cloud native providers want. And there is also some efficiencies and cost management capabilities which provide a lot of operational benefits, which are really gaps from the CDH or HTTP side of the world. But the native cloud providers have this core competency. So to summarize, both the paths meet in the same destination, a data cloud or data lake optimized for the cloud, also known as enterprise data cloud. In other words, a secure data cloud. So let's start with the customer's pain point. The pain here is the business or line of business wants speed and agility to meet business requirements. So this means onboarding net new use cases with agility to continually innovate and be ahead in their industry. However, the IT folks are concerned about ensuring that in addition to managing costs, there are security and governance controls applied so businesses won't run afoul of any regulatory or compliance issues. To balance both these needs is hard in a traditional monolithic architecture. This is because of all the different personas with their differing needs. For example, you have app developers, data engineers, BI analysts, data scientists, etc., that need specialized capabilities. These needs are what create tension between the two groups. And this is very hard to manage in a very monolithic architecture. So Cloudera's next-gen platform is able to manage both the requirements. So each line of business can have their own environment that they can use to customize their data life cycle, deploy on the infrastructure of the choice, use the choice of software version, their set of tools, etc. And this is what line of businesses are looking for. This is what enables a business to be agile and help them innovate in their industry. Meanwhile, the data is centralized with security and governance controls, which satisfies the IT requirements. So there are customers that have already got to cloud. So for customers that have ported their monolithic clusters to cloud, they struggle with agility and cost controls. For customers that started their journey via native cloud services, they struggle with centralized security and governance controls. So conventional wisdom says that if I start from a basic on-prem monolithic architecture and evolve that by pulling apart compute and storage, I've delivered a cloud-optimized equivalent, which means that I've magically got agility, elasticity, efficiency, and isolation, which is everything you're looking for in a modern cloud architecture. However, the problem is with the fine print. This only works for this simple use cases. For example, if your use case is a single tenant application where everyone has the same permissions to do everything, or it's just one workload, for example, a SQL workload, or it's non-sensitive data, or non-regulated industry, etc., this is pretty good. In fact, the basic tools you get from EMR or HDI is probably the way to go. For simplest use cases, you should use the simplest and the easiest low-cost tools available. The problem is those simple use cases do not include a data lake. Data lake requires much more than that. It requires state. So state is what makes it possible to track user identities in a consistent manner, to assign roles based on those identities, permissions based on those identities, etc. It is the ability to tag certain data with a certain type of quality metrics, to have a common schema. It's the ability to support the data lifecycle that is so prevalent in many enterprises, or the ability of 2 or 3 or more workloads interacting on the same data. Someone's reading from it using one component while someone's writing to it using another component. So a lot's happening with varied workloads running all the time. So state is referred to as a third element, with compute and storage being the other two. State is also commonly referred to as context or business logic or metadata, etc. So different people use different words, but the concept is the same. The key point being, you need state to provide discoverability of data assets, trust, for example, where is this coming from, compliance, reuse, sharing, etc. So these are all properties of the data lake. These are all required if your use cases are multi-tenant, where different groups, different departments need to do different things, either accessing different services or having different roles or accessing different data sets, etc. If your use case requires multi-workload, sensitive data regulations, etc., then you need stateful component to be present. The problem with conventional wisdom is that they have the initial picture wrong. So you don't have compute and storage. You have compute, state, and storage. And that's what your basic on-prem data lake architecture looks like. 5 years ago, before there was any kind of enterprise tooling available, maybe it was as simple as compute and storage. But in the last 5 years, between Ranger, Atlas, Knox, ID Broker, Metastore, etc., all of these elements have been building and maintaining state. The state is what makes it possible to build out an enterprise data lake. So when you go to a cloud architecture, you need some place for you to have that state. If you don't have it, you have a broken architecture. You can't put that state into compute because you will negate all the benefits of a cloud infrastructure. If I shut down compute, then I can't use state. If I have to use state, I can't shut down compute, which means that I can't grow and shrink the infrastructure. The compute needs to be stateless for me to optimize my cloud infrastructure. I can't put the state in the storage layer because of performance. For example, I can't have something like a Hive Metastore layer running on S3. There are things in development from the cloud native providers like Glue, etc., but these were where CDH 5.7 was years ago, like 3 or 4 years ago. You can't really wait for 2 or 3 years for those providers to catch up. You don't really have a place to store the metadata, the lineage, the audit logs, the metrics, et cetera, et cetera. So in essence, you're missing all of that. So let's talk about who specifically is experiencing these problems. So imagine you're having a meeting and 3 technologists walk into the meeting. Very commonly, you have someone identifying themselves as an engineer, an architect, or a business owner. Each of them have some requirement of the data platform. So if you look at the engineering owner, their job is to improve cost efficiencies, how to make it more cost efficient for the business. Their job is to break up large clusters. They want to take advantage of the object store to lower the cost of storage. They want to pause infrastructure when they're not using it. Everything should be provisioned dynamically, auto scaling, so a capacity plan is not required ahead of time. And they want DevOps model with infrastructure as a code. They do all the things here as a checklist, but it's a roadmap on how they're going to make the platform efficient. Now, if you take a look at the architect, they have different set of responsibilities. Their job is to protect the company. They need to do it in 2 ways. The first is from a security perspective. They need to ensure that only authenticated users are allowed to log in. They want to block anonymous users, and they need to ensure that the data is encrypted both at rest and in motion. They need to enforce the right permissions, typically following the rule of the least privilege. They want to capture audit and lineage information so you know who's accessing the data, where the data comes from, and where it goes. They need to apply all of these to comply with regulations. This is the roadmap that an architect follows to protect the company from a security perspective. The other responsibility is to protect the future roadmap of the platform. However, the business users' problems are a little different. Their job is to grow the business. Their roadmap is to scale usage. They want to add tenants. They want to add policies. They want to expand to newer markets in different countries. For example, USA today. They want to do Germany tomorrow, France day after, et cetera, et cetera. So with what these 3 personas don't know is that their roadmaps are in conflict with each other. The engineering owner says, remove state from the cluster to reduce cloud spend. Remove things like HDFS, the high metastore, metrics, audit, etc., so I can make the compute transient and elastic and minimize cloud spend. The architect's job is to capture more state to improve security and governance, like implementing Kerberos, for example, capturing audit, tracking lineage, etc., etc. This is in direct conflict with what the engineer is looking to achieve. The business owner is basically adding fuel to the fire by multiplying the state requirements, by adding permissions, filters, attributes, etc., in order to expand to these new geographies, add more tenants, and integrate their workloads. This is the dynamic that we see from the customers that are trying to run Hadoop in the cloud. Now, obviously, this is not good. It's kind of a bleak situation in many cases. These conflicting roadmaps create deadlocks. One is trying to remove state, other team is trying to add state, and the product team is looking to add more requirements for the state. Ultimately, they're stuck, and they end up optimizing for one at the cost of the other. So maybe I'll make it secure, but it won't be extensible or particularly cost efficient. I'll throw money at the problem. Maybe I'll focus on growth and throw money at the problem from an efficiency perspective and sacrifice security for some time. Neither of these options are particularly appealing or long-term approaches. So what is the answer to the need of the hour? The answer needs to be separate compute, storage, and state is the third element. There needs to be a place where you can take your on-prem data lake architecture and land the state in an easy-to-use service that is always on. That's easy to manage all of those elements out there. This is faster than the object store experience, but decoupled from the compute layer so you can manage costs from a workload perspective that you may need on the computing edge. This is true regardless of whether you're coming from an on-prem architecture or if you're coming from basic cloud-native architecture. Decouple storage and compute and build the security and governance on top of the state component. This is what is needed in the market to build an enterprise data cloud architecture, or said differently, a data lake on cloud infrastructure. And what is that? And that's SDX. SDX is the architectural innovation that makes enterprise data cloud possible. It is true that the end result is you have a secure and governed platform, and it's the reason why we talk about it as our secret sauce and the reason why customers are frankly excited about it. It's also the reason why our non-paying customers are also excited about it, because it makes it easy to run a data lake platform on the cloud. When you get the architecture right, and the reason why it's important, the personas that is under most stress is the architect. Architect is trying to get the architecture right. If you can get it right, then everything else becomes easy. It is possible when you have the SDX protection capabilities there, you can trust your company's most valuable assets to this data cloud platform because you know you got a secure architecture. And because you've taken the state from the get-go out of the computing environment, it becomes fairly easy to optimize for cost efficiencies. You can use all the benefits of the elastic infrastructure in a fairly straightforward manner, and the engineering job becomes that much easier. Finally, as a business owner, you've extracted all of this policy management, permissions, and the workloads separate from the infrastructure. You can change into new requirements, new geographies, and comply with new regulations without having to re-architect the platform over and over again. SDX automatically manages all the state required to build a secure data lake. So let's look at a few customer personas and their pain points. Let's start with the VP of Platform Engineering at a consumer credit reporting company. When we engaged with him to determine his pain points, he said he had a 600K CDH cluster on AWS, and it was costing him $3 million in spend. In the second instance, we have a chief architect at a social media and mobile application company. His pain point was that their cluster does not scale for their compliance and contractual requirements. Every time they have a new policy, they have one of the most brute force policies, they have to create a new cluster. The clusters are several hundred nodes. So when he saw SDX in action for the first time, his eyes lit up and he wanted to know when we were open sourcing this technology. In the last instance, we have a product manager. He is trying to build a multi-tenant cluster that aggregates all of the customer data from their different products. And they have 40 different products that they've either built or acquired over time, each with their own data source. His quandary was whether to build this himself or look at options in the market. So let's look at a few lessons from the front line. So a quick overview on this consumer credit reporting customer. The customer spends $3.5 million annually. Of that, Cloudera's licensing portion is $610K annually. So they have about 40 clusters and 1,000 nodes, and most of them are on-prem. They have some in some multiple different clouds, but we're going to hone in on one platform for this particular story. It is a product that they built a few years ago, and what it does is it pulls financial information on customers from all possible sources, anonymizes the data, and then sells it back to their end customer. So this kind of information helps their end customers like banks, etc., pull credit scores to help with loans. This is a revenue generating mission critical platform for this customer. So this is how their the current data architecture looks like. So to look at their overall architecture, they're using a multi-workload architecture, right? So it's about different workloads executed in different places. So EMR is used to ingest the data into Cloudera cluster. And then from there, they have various extraction, and some of it goes into Athena and other EMR clusters, etc. The future involves moving them from CDH to CDP, where they can run the data hubs, which roughly reduces their AWS cost by $2 million to $1 million, or 67% from their original cost of $3 million. This allows them to use the object store S3, provision dynamically, secure the cluster, etc., etc. And this is only stage one. There are other stages planned as well, which include geography expansions, etc., etc. So capabilities like security, governance, and multi-tenancy were not as good with EMR as compared to CDP. And this is the reason why this particular customer chose to go with CDP instead of migrating everything to EMR. So to do something in EMR, for example, they have to embark on a lot of DIY projects. For example, if you want to enable Kerberos on EMR, you have to read a 25-page blog and try to figure out how to enable that so your clusters are secure. If you want to run some kind of if you want to enable audit logs, for example, in EMR, there's another blog post that you have to follow to enable that. So there's a lot of those things that come as part of CDP that you have to do it yourself in order to get the same benefits on some of these providers. So let's look at the challenges and the impact and the solutions and then the outcome, right? So from a challenge perspective, the customer needed very agile, low-cost product footprint for exploring and launching new products in new international regional markets. So they needed multi-tenancy performance and they needed a lot of security. And then they also needed to make sure that this content was isolated really well. So multi-tenancy is a huge, huge ask here. Global data considerations that conform to localized and geographical restrictions and limitations are also a big deal here, right? So they wanted to ensure that they have enterprise security and isolation of contention, and they wanted to ensure that their end user experiences were not only met, but exceeded. They wanted to ensure that they were able to scale, and the cost efficiencies were also needed to address both large and small customers and prospects. And what is the impact? The impact was the revenue opportunity requires massive data sets to be available to multiple customers. And the current solutions were not ideal. For example, CDH was not very elastic, and EMR had a lot of multi-tenancy challenges. So what was the solution for this particular case? So it was CDP Public Cloud. So CDP provided a single solution to enable build once, deploy many standardization benefits. So it also provides multi-tenancy performance, security, and contention isolation. Provides elasticity to maintain operational costs, maintain costs and then minimize it. Can also have minimal initial footprint and scale exponentially as needed as new market opportunity materializes. So which means that you don't really need to you plan for a capacity and then procure everything. You can start to procure footprint as needed and scale as needed. So the outcome, the projected outcome, was greater architectural elasticity and flexibility, lower operational cost of multi-tenant product, which means increased profitability, and the potential for savings were over 100K per month on AWS compute costs. This is pretty huge. Improved end user experience, which means better and more consistent performance, less issues, improved security and privacy, etc. So standardization, essentially reduction of multiple products and architecture into one single standard, which means that you have less challenges and you have less costs, training different personals on using different tool sets, etc. And then low-cost, small footprint solutions to explore new market, which means that you're looking at revenue well over many millions. So cost efficiencies allowing price points to address mid and small market prospects where the revenue growth is estimated to be over many millions of dollars. So let's look at some key takeaways, right? To summarize, we can help customers move their legacy CDH or HTTP clusters running on an IaaS model to CDP and take advantage of SDX and cloud native features. This helps with cost management, features like auto scaling, deprovisioning of clusters when not needed, etc., etc. These are truly cloud native services that can help manage costs. We can go on the offense and rescue customers that have DIY projects or struggle with multi-tenancy problems. Multi-tenancy is a big deal, especially when you're looking to provide the isolation between different users. And you can also try to rescue customers that have to deal with the nightmare of managing cloud credentials with CDP. We can help resolve conflicting blocking requirements between different personas like engineers, architects, line of businesses, and help the business innovate. We can address all the stages for traditional and the evolving data lifecycle with streaming data, all within the data platform secured by shared data experience or SDX. Here are some examples of objection handling. For example, if the engineering owner says we can get EMR for 10 cents instead of 12 cents, then the response is pretty simple. It's not about unit cost. It's actually about efficiency, right? So this is about total cost of ownership. The architect can say we can build it ourselves, and the response is it is just not Kerberos. It's many features. It makes more sense to buy versus build, as this is not the business that your enterprise is in. The architect can say we can use glue and data lake formation, et cetera, et cetera. Absolutely. If you want to wait for 2 or 3 more years to catch up to our technology. However, if you want something right now that provides finer grained security controls, lineage, governance, et cetera, that is mature, then SDX is a choice. It's worthwhile noting that the underlying components of SDX has been in use at major financial, healthcare services, et cetera, for many, many, many years. So let's summarize the call to action. We can go on offense in 2 ways. Position CDP public cloud for net new use cases. The shared data experience, or SDX, or state is unique to Cloudera. We can compete effectively with the cloud vendors by positioning its value to build out a true multi-tenancy and helping customers on the journey to align their cloud journey with their business maturity. Likewise, we can go on defense in 2 ways. Migrate early stage customers to CDP public cloud directly. Help transition customers who have deployed CDH or HDP in public cloud in an IaaS model to CDP public cloud. So thank you for taking the time to watch this enablement. I look forward to seeing you in the next enablement.